Okay, in the checkpoint problem for example 1, we're given tangent of x is equal to 8 over 15, and secant of x is equal to negative 17 over 15. So if we make our hexagon, we'll have an x with a line through it, and then we can connect to make 6 triangles in the hexagon. Remember, the center always gets a 1. And then the farthest left vertex is the tangent. And then we use our quotient identity to go around. So tangent is sine divided by cosine. And then we can use the reciprocals. So the reciprocal of cosine is secant, reciprocal of sine is cosecant, and reciprocal of tangent is cotangent. And that's how we set up the hexagon. So next we'll put our given information in, and tangent is 8 over 15. Secant is negative 17 over 15. And we can use our reciprocal identities then. So cotangent is the reciprocal of tangent. So we'll flip that fraction upside down to get 15 over 8. Okay, then the reciprocal of secant is cosine, so we'll flip that fraction upside down and get negative 15 over 17. And then that leaves sine and cosecant. And one of the options that we have is to use the quotient identity. So remember, we could go clockwise here and get the identity that the cosecant of x is equal to the secant of x divided by the tangent of x, right? That would be these 3 vertices. And if we substitute in what we know, cosecant of x then would be the secant, which is negative 17 over 15, divided by the tangent, which is 8 over 15. And when you divide fractions, you multiply by the reciprocal. So negative 17 over 15 times 15 over 8. The 15s will cancel and leave us with negative 17 over 8. Okay? And that would be the answer to the cosecant, negative 17 over 8. So the last one would be the sine, and since that's the reciprocal of cosecant, we can just flip that fraction upside down to get negative 8 over 17. And now we have evaluated all 6 trig functions for the given information.